back. We're going to take a look at another practice problem from our worksheet on calculations involving equilibrium constants, KEQ. We're going to skip ahead here and look at number 13. All right. Question number 13 says, at a certain temperature, and it needs to be a certain temperature because KEQ is temperature dependent, so we're just saying at a temperature, it doesn't matter what temperature, just at that temperature. Carbon monoxide and water enter into an equilibrium with carbon dioxide and hydrogen gas, and it is a KEQ of 0.400. Exactly 1 mole of each gas was placed in a 100-liter vessel, and the mixture is allowed to react. It says find the equilibrium concentration of each gas. This question is a little bit trickier than it looks, so let's break it down. First, our reaction. CO gas plus H2O gas enters into equilibrium with CO2 and hydrogen. Just putting a double line here under the arrow to separate my reactants and products. All right, so we're told in the question that exactly 1 mole of each gas is put into this system. So we've got 1.00 mole divided by 100.0 liters. So we end up with 0.0100 molar. Next, we define the change. Now we're given the KEQ is less than 1. Now when we're interpreting KEQ, a KEQ greater than 1 means products are favored. A KEQ less than 1 means reactants are favored. And if you look close, these here are all the same value, 0.01. We added 1 mole in a 100-liter vessel of everything. But since KEQ is 0.4, when we look closely here, they're not favored. Reactants need to be favored. So these are going to increase in order for reactants to be favored, for there to be more of them. And our products will have to decrease by some value, X. Now at equilibrium, 0.0100 plus X, 0.0100 plus X, 0.0100 minus X. All right, so now we know the initial concentrations. We're able to interpret KEQ to show that reactants need to be favored to have a value less than 1. So to favor the reactants, they have to go up. Products have to go down by some value X. And here's our equilibrium concentrations in terms of X. Now, KEQ is equal to the concentration of CO2, the concentration of H2, these are all gases, divided by the concentration of CO gas and the concentration of H2O gas, water vapor. Now we know what some of these values are. We know KEQ is 0.400. We know the concentration of CO2. CO2 is 0.0100 subtract X. And we know H2 is 0.0100 subtract X. Our concentration of our reactants well, we need to solve for X. Let's try this. We got 0.400 and we've got 0.0100 subtract X squared over 0.0100 plus x squared. So we'll simplify it. Well, let's take the square root of both sides. .632, I'm going to store that there. That's 0.632 is equal to 0.0100 minus x over 0.0100 plus x. So take the square root of both sides and we simplify. Now we're going to multiply both sides by our denominator. We use the distributive property. We'll combine like terms, so we'll add x to both sides. So we got 1.632x is equal to is equal to 0.00368. So subtracted 0.00632 from both sides. Added x to both sides, we combine those terms. We'll divide both sides by 1.632. X equals 0.00225. So we have to find the equilibrium concentration of each gas. Well, the concentration of CO is equal to 0.0100 plus x. X is 0.00225. And that's our final concentration of each value. Now we can check our answer. We're supposed to get 0.4 if we plug it into this. So let's see if we get 0.4. So our products were 0.0078. We had two of those. And we're dividing that by our reactants here. So that was... And we get 0.402, which, with rounding error, that's the 0.4 we were shooting for. All right, that was number 13, algebra. Have fun.